Everyone, and welcome back. It's Kira Garfolo with Greenville Tech's Math 155. Today we're going to talk about section 2.5, which is measures of central tendency. So what is central tendency? Well, we're going to continue our discussion today with statistics by talking about some characteristics, let's say, of data. And one of these is called central tendency. Central tendency is more like the center of the data. Where does that data tend to hang out or gather in its middle? Okay. Another way to think about it is if you're thinking about that data set, what would you consider to be a typical value for the data set? These are all getting at that idea of central tendency. Most commonly, we'll use the mean for central tendency. And you guys have probably used the mean before, but maybe didn't call it the mean. The mean is just the average, okay? In plain English, it's the average. So you guys have all talked about averages before. Think about your test average for a class, right? To calculate the average, we're going to talk about the formula, but you guys probably already know how to do it. Something important to note, just like we have seen with some other things, and we'll see in the next section, the population and the sample will have different symbols, but the same calculation applies, okay? When we're working with a population, so remember that whole group of interest, we're going to be talking about mu, which is this Greek M marrying a U symbol. And if you're working with a sample, which remember is a subset, which is more commonly what we see in the real world, you're going to have X bar. It's just an X with a little bar on top of it, okay? To calculate the mean with mathematical formulas, you have either of these formulas up here. Notice they're doing the exact same thing. We just have slightly different symbols. We have X bar for sample and we have mu for population, and the same thing. We have N with a capital for population and lowercase n for a sample. This symbol right here looks like a weird E, is a capital sigma, and it just means to sum, okay? So for these, sum of X means add all of your X values. Basically, these fancy looking formulas are just telling you, hey, add all your values up and divide by how many of them you have. Your units for the mean will always stay the same as the original data. So if you're talking about inches for height, then your average also is inches. Let's talk about an example here. Let's find the mean of the numbers 4, 7, 8, 10, 12, and 15. Well, to find that, we're going to just simply add all of these up and divide by, we have 1, 2, 3, 4, 5, 6 of them. If we add them up and divide by 6, or if you want to do that in your calculator all at once, use the fraction notation or use parentheses, and you should be able to see that you get 9.33. Repeating, but we'll just cut it there. If we want to find the mean of these incomes, we're just going to add them all up. And we have 1, 2, 3, 4, 5. So if we add all 5 of these up and we divide by 5, you should see that the average is 41,000. Okay. Again, you're just adding all of them up and then dividing by 5. Let's find the mean of these test scores. Take a break, pause this. It takes a minute to put all of these in. But when you add them all up, you should get 1623. And if you count them, there are 20 of them. I don't want to waste your time showing you on a calculator. You guys know how to add and divide. But you should end up with 1623 over 20. And that will give you 81.15 as your mean. Okay? Again, good idea to pause and make sure you can get that. These are easy test questions. Don't give them away. Now let's talk about a little bit more of a complex example. Let's say that Sam bowled 3 games with scores of 210, 185, and 190. He needs to have a 4-game average of 205 to qualify for a league. What does he need in order to get that 205? So on that 4th game, what does he get? Remember when we have an unknown that we'll usually represent that with X. So we can say, okay, well, game 1, game 2, game 3, and game 4. We know that game one, he had a 210. We know he had a 185. He had a 190. And then we don't know what he's going to get there. He needs, and we want the average to be 205. So that means out of the 4 games, we need 205 to be equal to the average, which is just going to be 210 plus 185 plus 190 plus x divided by 4. Which we can see is 205 equals 585 plus x divided by 4. Now you guys have done this in unit 1, right? We're just solving for x. So multiply both sides. When we multiply 205 by 4, we're going to get 820. So we'll have 820 equals 585 plus x. And if we subtract 585 from each side, we're going to get that 235 equals x. So he needs to bowl a 235 to make his overall average 205. Now looking at his scores already up here, not looking good for him, but it's totally doable, right? He could bowl a 235 really easily. Okay. Now sometimes we don't just want the mean, okay? Sometimes the average isn't a good idea. And again, in Math 120, if you take probability and statistics, come take it with me. It's one of my favorite classes. But we'll talk about the pros and cons of a lot of these, okay? And we'll talk briefly about it in this class, but there's a lot more theory behind it. So another common measure of central tendency is the median. So instead of just calculating the average, we also can calculate the median. And the median, think about it as the median in the road, right? It's in a dead center. So to find our median in a data set, we want to find the middle value of the data values, okay? We're not adding anything together now. We're just counting how many there are, and we're finding the middle of them. There's something very important here. It must be arranged in order, okay? Put your data from smallest to largest. If you don't put them in order, you will get the wrong answer. Sometimes you'll get really, really lucky, but almost always you're going to get the wrong answer. Now, if your number of observations is odd, so count how many you have. If it's odd, then just look for the middlemost observation. What value would give you that you have the same number on the left as you have on the right? If it's even, then you need to find the middle 2 observations because you're not going to have one middle one, okay? Find those middle 2 and take the average of those 2. You must put your data in order. Otherwise, you're going to miss this answer, okay? Okay. Finding the median, some examples here. For our first example, we have 2, 4, 5, 8, and 10. The first thing we do is count. We have 1, 2, 3, 4, 5, so n equals 5, which is odd, okay? So we have an odd number. We're going to find the middlemost. They're already in order. So the middle one here is pretty easy to see, 5, right? We have 2 on the left and 2 on the right, so 5 is our answer. So our median is 5. Now for the next one, we want to find the median of this data. Notice that the first thing we need to do is put them in order. They're not in order, okay? So pause for a moment if you need to do that. But putting them in order, we're going to have 64, 67, 68, 70, 75, 80, 80, 80, 83, 84, 89, and 103, okay? Good idea to mark them out as you're writing them, whatever, count how many you started with, count how many you ended up with, make sure you don't lose one. Sounds trivial, but it's incredibly easy to lose one, okay? So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is even, right? So now we need to split the data in half. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that line splits our data perfectly in half. To get our median, It's going to be the average. That looks like August, but it's the average of 80 and 80. Now we could add 80 plus 80 and divide by 2, but the average of two identical numbers is still just that number. So our median is going to be 80. Okay. Now we can talk about the mean versus the median as well. Okay. The median is better suited for data sets that have extreme values. Okay. The mean gets very much impacted by these values. So now the mean isn't a very good representation of the center. For example, talk about the mean and the median for each of these data sets. Okay. So we'll call this 1 and we'll call this 2. The mean and the median. The median for both of them is going to be 3. The mean for the first one is also 3. We can see that pretty easily. But the mean for the second one is going to be 102. Okay. Notice how different this is. 102 is not a very good representation of the middle or a typical value for these, right? So when we have those extreme values like 500, we want to use the median. Which one will be higher? Sometimes the mean is bigger than the median. Most commonly, that's going to happen when we have something called skew. Again, I'll save that for 120 if you'd like to take that. But those outliers or those extreme values are going to pull the mean towards it. So it depends which side your extreme is on as to which one will be bigger. You can always calculate both of them and see. In addition to the mean and the median, we also have what we call the mode, and this is everybody's favorite to calculate. The calculator does not give us the mode. As we'll see in a minute, there's a way to get most of these in the calculator, but the mode does not have such. The mode is simply what number or what observation appears most frequently, okay? So you can have one mode if only one number repeats the most. You can have no mode, or you can have multiple modes, okay? So for example, if we have this data set, our mode is 2 because 2 repeats. If we have this data set, we have no mode because nothing is repeating. And if we have this one, we actually have 2 different modes because 3 is there twice and 4 is there twice. Now, something else I like to mention is just because it repeats does not make it a mode, okay? So if I have 1, 2, 2, 3, 3, 3, 4. In this case, even though 2 is there twice, so 2 repeats, 3 is there 3 times, okay? So the most repetitions are 3. So in this particular case, my mode is actually going to be 3, okay? 2 is not a mode here. Just because it repeats, it does not make it a mode. Let's look at some examples. Go ahead and pause and make sure that you can answer these also. So the mode for this first one, we can count how many things appear many times, but we see that 3 occurs the most, okay? Our mode here is going to be 3. The second one, we have to kind of be careful. Makes my eyes hurt. I'd maybe put it in order to see. But it looks like the one that repeats the most is 75. We see a couple that repeat twice. But 75 appears 3 times, and I don't see anything else that repeats 3 times. So our mode would be 75. Now, remember we talked about in frequency distributions that sometimes we have grouped data, right? Sometimes we have classes. So instead of looking at 1, 2, 3, 4, 5, maybe we're looking at scores of 1 to 9, or 0 to 9, 10 to 19, 20 to 29, and so on. In this case, we need to consider the frequencies. Even if you have just the measures of 1, 2, 3, 4, and you're counting how many of them there are, you will need to consider the frequencies. To calculate the mean in this case, you're going to look at how many are in each, we're going to look at how many are in each class, so F, frequency, and we're going to multiply that times its value. And for every class, we're going to add those up. There's that summation again. And then we're going to divide it by how many we have across the frequencies. This is a lot easier to show in an example, okay? The median is going to be the middle, and we're going to use the frequencies to find what number would be in the middle, okay? And the mode is definitely the easiest. In this case, it's just going to be what occurs most often, okay? So what class has the highest frequency? Let's look at an example here. We want to find the mean, the median, and the mode. So to find the mean, a lot of times if I'm going to do it by hand, I will just put a little thing over here that says X times F. And I'm going to have 62 times 20, which would be 1240, and so on, okay? The mode is the easiest one to do first. Let's do that. Ran out of order here. Our mode is our most frequent value, okay? We see that 30 is the highest frequency, so 64 is going to be our mode. Mode's always the easiest one just to look at real quick. Now back to the mean. I jumped the gun there a little bit. We are going to add up this times this times this, plus this times this, plus this times this, plus this times this. Again, be careful with PEMDAS, right? Our order of operations. If you put it in the calculator, make sure you put parentheses here, or use that math print fraction. So we're going to add up all of those products. Then we're going to divide it by the sum of this frequency column. So 20 plus 30 plus 25 and so on. When we get our answer here, we see that our mean is 64.89. Now to find the median, we need to first know how many observations we have. We see that we have n equals 90. We know that from down here, right? 20 plus 30 plus 25 plus 10 plus 5 is going to be n equals 90, okay? The middle of 90, it's an even number, so we would need the middle two, which would be the 45th and 46th observation. In order, these classes are in order, so we're fine. We're at 20 observations here, and by the time we add all the 64s, we're at 50 observations, right? Because the first 20 are 62, and then the next 30 are 64. So our median is going to be the middle of the 45th and 46th. If this one goes up to 50, then 45 and 46 have to be part of this 64. So our median is the same thing as our mode, which is 64. Let's take a minute and pause, and you can solve this one as well. Okay, let's find the mean first. So to find the mean, we're going to have 110 times 4 plus 140 times 20 plus 175 times 15 plus 200 times 5 plus 250 times 6. That's going to be our sum of the products. And then we need to divide it by 4 plus 20 plus 15 plus 5 plus 6. Okay. And so that bottom is going to be 50. If we type this in our calculator very carefully, we're going to get 167.3. That's our mean. Now our median, we know the n is 50, okay? Because if we add up if we add all these up, n is going to be 50, right? And so the middle of 50 would be, the middle two would be 25th and 26th observations. If we add them up, these are our first 4, and then we have 24 by the end of 140, and then we list the 175s, and we'd be up to 39 here. The 25th and 26th observations have to be 175. So the average of 175 and 175 will be 175, okay? So our median is going to be 175 here. Our mode is the easiest. And we see that the highest frequency is 20. So it is going to be 140. Okay. Make sure that you can make these make sense. I'm going to show you a shortcut with your calculator here in a little while, but the mode, again, does not come out on your calculator. Okay. Now, sometimes our data is in a frequency distribution with classes. Okay, so we don't have a single value. We're not talking in this case like 110, 140, 175. We're talking about maybe 110 to 135 and 135 to 1 whatever. Okay. In this case, it's a little beyond our class for the most part, but in this case, we're going to use the midpoint of each class. Okay. The rest of the formula works the exact same way, but we're going to use the midpoints. It's not perfect, but it's our best guess. Okay. We're only going to do the mean in our class. We are not going to do the median, and we're not going to do the mode. Okay, because it gets a little tricky with those classes. Let's talk about an example here. The first thing we need to do is talk about the midpoints. Okay, so the midpoint is just what's in the middle of that class. 10 is going to have a midpoint of 5. 10 to up to 20 is going to be 15. And our class width is going to play that same leapfrog concept. Okay, 25, 35, 45, and 55. Those are going to be our midpoints. Now, if we want to find the mean, everything else is going to work the exact same way. Instead of X, we're going to use our midpoints here. Okay. So this is going to give us an average of 31.25. So if you're talking about group data, and again, I'm going to show you how to do these in your calculator here in a minute. You won't be able to do it with classes. You're always going to have to find the midpoint if you have these classes like this, okay? And then everything else goes the same as the group data that we just saw. Now, measures of position. What do I mean about measures of position? I've talked about central tendency, where it's where the data groups, okay, where the center of that data is. But now, measures of position, instead of talking about the overall data group, you're concerned about one observation, okay? And you're talking about where a certain value is going to fall with respect to the rest of the data. So if you took a test, you don't necessarily care about how the whole class did. You care about how you did. Compared to everybody else in the class, how well did you score? When you take the SAT, how well did you do relative to everybody else, right? How does your salary compare to those in your field? Should you ask your boss for a raise? There's a lot of ways to talk about measures of position, but in this class, we're only going to talk about quartiles and percentiles. In a percentile, we're breaking the data into 100 pieces, okay? So 100%, 100 pieces. The percentile is just the percent of data that is at that score, well, below that score or value, okay? So what percent of the data fall below that score? For example, you've done some research and you found that your salary is in the 16th percentile for peers with your career and experience level. So all other things equal, you're in the 16th percentile. What does that mean? Well, it means that 16% of people make less than you. But if 16% make less, then 84% have to make more. So maybe you should ask for a raise, right? Let's talk about another example. On a standardized test, Rachel has scored in the 85th percentile out of 1,000 students. Okay, so what does that mean? Well, that means that 85% scored below Rachel. Okay, and that also means, on the other hand, that 15% had to have scored above. So she did pretty well. 85% scored below her. Only 15% did better. So how many students scored below Rachel? Where? Well, 85% of 1,000 scored below her. So that's going to be 0.85 or 85 over 100 of 1,000. So times 1,000, just like we learned in Unit 1, which is going to be 850. 850 students scored less than Rachel. How many scored above Rachel? Well, this is one thing. There's just one little minor thing here, okay? There's 1,000 students, and we know that 850 scored below Rachel. How many of them scored above her? Well, we might want to think, oh, well, 1,000 minus 850, or 15% of 1,000. But in this case, we wouldn't take Rachel's score into account, right? So we know that 850 of them scored down here. And then we have Rachel's score. And then we have everyone else. Okay. So Rachel counts for 1. Okay. Everyone else has to be 850 plus Rachel plus the people that scored above. So that's going to be 1,000 minus 851, which is going to give us what, 149, I believe. So 149 people did better than her. 850 did less, and then she is that 1,000th score. Okay, so in addition to percentiles, we can talk about something called quartiles. And quartiles just break the data into 4 parts. So percentiles, break it into 100%. Quartiles, quart, 4, right? Quarters. So now we're breaking it into 4 pieces. Now to break something into 4 pieces, it's tempting to say you need 4 numbers, right? But you don't. You only need 3. Think about breaking a candy bar into 4 pieces. You only need to make 3 breaks to get your 4 pieces. So our 3 quartiles are Q1, Q2, and Q3. And Q1 is the lower quartile, the first quartile. And it has 25% of data below it, okay? Q2 is actually our median. It's where that 50-50 break is, okay? So Q2 is the median, 50% is below. And then Q3 at 75% below, okay? For this reason, you can think about it, right? You can think about this as percentiles. Q1 is the 25th percentile. The median is the 50th percentile. And Q3 is our 75th percentile. If we want to calculate quartiles by hand, notice we didn't talk about percentiles by hand, and we won't do percentiles by hand in this class. But if we want to calculate quartiles by hand, it's similar to finding the median. Okay, if you liked finding the median by hand, you're in luck because you're finding medians a few times here. The first thing you must do is put that data in order. Again, if you don't put your data in order, you're going to be in a world of hurt. You're going to get a lot of wrong answers. The first thing you want to do is find the median. That's Q2. So you've already found one of your 3. Find the median. Then you're going to only look at the lower half of the data. When you find the median of the lower half of the data, that's going to be Q1. Then when you look only at the upper half of the data, you're going to find its median, and that's going to be Q3. Voila, that's your answer, okay? Let's learn this through an example. An electronics store is concerned about how high turnover is of its sales staff. They did a survey to see how long the sales staff had been there, and here are the responses of 27 sampled staff, okay? We want to find all 3 quartiles. We get this data, and the first thing we want to do is put it in order. And I've done that for you here to save some time, okay? So we're going to put it in order. We had n equals 27 with an odd number, okay? So our median is our first step, and the dead center is what we're looking for here. So the middle of 27, you're going to have 13 on the left of it and 13 on the right of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 on the left. Our median is 17. Let's verify by making sure there's also 13 on the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. So this is Q2. which is also our median, okay? Now to find Q1, we need to look at that first half of the data and find its median. The only sticking point here is make sure that median serves as a fence post, okay? So when you're looking for Q1, only consider these numbers here, okay? 17 does not get included anymore. Your lower half is below it and your upper half is above it, okay? Don't include that fence post. So remember, we have 13 in each half. So the middle of this lower 13 is going to be observation 7, right? You're going to have 6 on the left and 6 on the right. So 1, 2, 3, 4, 5, 6. 9. Check, make sure there's 6 on the other side. 1, 2, 3, 4, 5, 6, and there is. So that's going to be Q1. We're going to do the exact same thing over here, 6 on each side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're good. So we're going to see here that our Q1 is 9, our median, which is Q2, is 17, and Q3 is going to be 24. I worked through that a little bit quickly, but make sure that you can pause, go back, and solve it on your own. Now, I've alluded to this a couple of times, and it's going to make our lives so much easier, okay? You can get your answers in the calculator too, okay? And I'm going to show you how. We're going to go into our calculator, and we are going to clear our data. So remember, press data twice and 4, okay, to clear your data. So now we have an empty table, okay? We're going to enter our data in L1 right here. If you have a frequency distribution, enter your data at L1 here for X values and your frequency over here, okay? Then you're going to go into one variable stat. So you're going to press second stat, which is second data, and you want one variable stats, okay? And that's going to show us how to get there. I'm going to quit this because it's going to be a lot easier for us to see with actual data here. These instructions are here for your reference, but please note that there's tons of information that's going to be output. You're going to have N, which tells you how many observations you have. It's always a good idea to double check that and make sure you didn't forget one. You're going to have X bar, which is going to be your mean. It's going to tell you the median as MED, and it's going to tell you your quartiles, so Q1 and Q3, okay? Let's look at an example. Let's find the quartiles for that data that we were working with earlier. We're going to enter it into our calculator, probably painstakingly slowly, right? So we have, they're all going to go in one column here. 88, 63, 90, 64. I'm going down my columns, by the way. 82, 99, 75. We do not need to worry about putting them in order. For our calculator, it's smart enough to do it for us. Just make sure you don't miss one. But hopefully I'm not missing one by speaking at the same time. Oh my goodness. Okay. So let's find these. Oh no, I missed one somewhere. Oh my goodness. Let's see. I'm just going to go all the way back up because I know that I should have 32 of them. Okay, so 88, 63, 90, 64, 82, 99, 75, 75. Oh, there's my mistake. So I just need to add a 75 at the end of these. Always good to check that in. See, none of us are immune. Okay, if I want to find these quartiles with my calculator, I have my data in. So now I'm going to press second data, which is going to take me to stat. And I want one variable stat. L1 should be highlighted because L1 is where I put my values. And here, I don't have a frequency distribution, so I actually want to highlight 1, okay? Unless you have a frequency distribution, you want L1 and 1, okay? Because this is saying, hey, I have a frequency over here. This is saying, hey, only my numbers, I put them in as they are. It's just a list of data. Don't duplicate anything beyond what I've already duplicated. Press calc. And it's going to give us tons and tons of information. You guys probably remember back from when we did the graphing, right? When we found the slope, there was tons and tons of information there too. This is one variable stats, not two, so pay close attention to that. But now we see n, we see x bar, we see our standard deviation, which we'll talk about in the next section. We see all kinds of stuff here. We see the min. We see Q1, which is 69. We see our median, which is Q2, which is 77. And we see our Q3, which is 85.5. So that's a whole lot easier than finding them yourself, right? Especially if I ask you for multiple things about it, like I will on the test. So there's your quartiles. And if you wanted your mean, there it is. Now, again, remember, it's not going to tell you about the mode. It's only going to tell you about all of those other things. Let's see, I was looking to see, it doesn't look like we found the mean for that data, did we? Nope, we didn't find the mean. I was going to verify it, but we didn't find the mean for that data. The mean here is 76.5 rounded to 1 decimal place. If we want to go back and find the mean from one of our earlier examples, we can say, okay, quit. I'll press data twice and press 4 to clear it. Let's do that very first example that we did. We had the numbers 4, 7, 8, 10, 12, and 15. We're going to go here, one variable stat. Again, we're just listing our data. We're going to press enter. And we see that our mean, just like we found before, is at 9.333. So we didn't have to add, divide, anything like that. We just found it on our own. Let's go back and do the other example real quick with the frequency distribution. I'm not going to have you do one with the classes, although you would just put midpoints in for your x's. But let's find this one. Okay. So when we have a frequency distribution, we're going to press data again twice and clear everything. The first column is our x values. The second column is our frequencies. So here we have 110, 140, 175, 200, and 250. And our frequencies are 4, 20, 15, 5, and 6. If we want to find the mean here, we found it by hand as 167.3. Let's verify that in the calculator. And on your test, you're probably going to do it in your calculator, right? You're not going to do it by hand. You're welcome to, but most people prefer to not do it by hand. We're going to press second data to get the stats, and we want one variable stats again. Now there is a small change here. Our data is L1, okay? But now instead of frequency being 1, we want to say, no, we put our frequencies, we put a frequency distribution in here. So our frequencies are actually in L2, okay? And that's going to tell us that we're dealing with group data. When we press calc, it's going to calculate those for us. And sure enough, our mean, just like we found before, is 167.3. The median is going to be down here too, as 175, which remember that's Q2. You could find your quartiles, you could find all kinds of stuff in this one variable stats. So definitely take advantage of your calculator, okay? Okay, so what questions do you have as we wrap up today? Write them down, give yourself a break, come back. If you still can't figure them out, make sure that you seek help to get them. Remember that there are those additional resources in Blackboard. There are other lectures, other videos, practice problems, things like that. Your textbook has tons of practice problems. Make sure that you're practicing by hand for the simple ones and with your calculator too. I have no problem. I'm not going to say you must do this by hand on your test, but I do want to know that you know how to get the answer, whether it's in your calculator or by hand, okay? If you need help, I highly encourage you to go to the Math Center, or you can reach out to me by email or in office hours. Remember, it's a good idea to email me for office hours too. Just let me know you're going to be stopping by. And remember, you have tons of practice problems at the back of each section and also throughout the sections in your text. Remember to check your course schedule for any assignments and tests. We're getting close to the end of a unit, so you know what that means. And if you have any questions, remember to reach out. Thanks as always for tuning in, and I will see you guys next time.